Bene, buongiorno a tutti.
Good morning to you all, and welcome to this session, Young Italians at the Forefront of Science. Today's session provides us an opportunity to meet two young Italian researchers, as you can see, doing scientific research at international level. They do scientific research in their fields of study. They will talk about that, so I'm not going to dwell upon it. So we've got with us Stefano Facchini, researcher at the Max Planck Institute. So researcher at the Max Planck Institute for Extraterrestrial Physics in Garching in Germany. And Tommaso Fraccia. He is a researcher at the University of Milan and at the San Raffaele University in Rome, and is about to go to Paris at the Institut de Gênes to continue his research. So we've got with us two young Italian researchers with an international dimension. And they do research in one of the most interesting and I would say exciting fields of science. Which are connected to all the activities that were presented here at the meeting this year. So their presentations will be very precious for us all. We will be able to understand the difficulties, the reasons, the wide horizons of their research, hence the desire and enthusiasm for research. This is at the heart of their experience, both human and scientific experience. The human and scientific dimensions are both necessary for all researchers. And I think that it is quite uncommon to talk about it in a very simple way, as they will do. So, as I said, you know, their research is strictly connected to the topic Euresis, which was presented this year at the meeting. So we presented this activity on extrasolar planets, on the origins of life on Earth, and the possible life elsewhere in the universe. The topic of science has been debated for many years here at the meeting without separating the human dimension and the scientific one. Because science is a human activity. So over many years, we dealt with many different topics in order to learn something new from the dialogue with also participants in the meeting. This year, things were even more beautiful. There is a new generation of scientists, as we have seen. Tommaso and Stefano were a sort of benchmark for them. And they were the ones presenting this work in the exoplanets area. This is why I'm really interested in talking to Tommaso and Stefano and hearing what they will have to tell us. So I will start by asking a question to them. Can you tell us what's your field of research? What have you done in order to get there? And how have you developed your interests? Because deciding to do a research requires making a decision. Maybe you could start, Tommaso. Off you go. Thank you, Marco. Thank you, Marco, for this introduction, and thank you for inviting me here. It's really an honor for me. I study liquid crystals of DNA and their potential implications to understand the mechanisms leading to the DNA and RNA nucleic acid, which are fundamental for life. I have prepared just a few slides for you. Now, you can see a few images here, and these are liquid crystals which are made of DNA at the microscope. What is striking is these shapes, these colors, very bright colors on a black background. I will continue speaking about that later on. I imagine that when you hear the word liquid crystals, you don't think about the DNA, but you immediately think about your smartphone or your TV screen. And that's true. Now, inside our screens, there's liquid crystals. Now, if you had a magnifying glass, or if you put a water drop on the screen, a small water drop on the screen of your mobile phone, you could see that inside there's pixels, as in small squares, where you have the three different colors, as in red, blue, and green. If you could look inside these little squares, you could see liquid crystals. Now, liquid crystals are a sort of ordered fluid consisting of molecules with a very peculiar shape, a long shape. Thanks to that shape, they can be different from other molecules. So if you imagine that a liquid crystal has this shape, like a stick, you can have like toothpicks, which are scattered around and at random, and this is a liquid state for the matter. If you increase the number of these toothpicks, or if you change the temperature, then the toothpicks would go all along the same direction, making up an ordered system because they all tend towards the same direction, but it's still a liquid system. And this is the crystal liquid state. And if you fill up the whole box, you can have a solid crystal. Now, what is peculiar about crystal liquids, where I study, my lab, is that they are made of DNA. The DNA has a molecular shape that can make liquid crystals. It's a very stiff double helix. What is interesting is that we started to work on small bits of DNA, and even the small bits of DNA can give disorder to liquid crystals. And the way they do it is quite surprising. the small bits of DNA pile up one over the other as if they were like tuna tins, one on top of the other, and they make up like columns. And these columns can show this liquid crystals. What has it got to do with the origins of life? This is a very recent discovery. We have seen that the different bases of DNA have the same features. So, for example, if you get A and T, they couple and they can make up columns where the nucleotides are in the same position where they would be inside a DNA polymer. It's as if the tendency to have a DNA was already enshrined in what they consist of, in the elements they consist of. So this is what I do research on. I studied in Milan. When I was doing my thesis, I started working on this topic. Then I attended a PhD, a postdoc. And then I became a researcher, not at the University of Milan, but at the University of Rome. And therefore, I could continue my research in the labs of Milan of Professor Tommaso Bellini, who is here in the audience today. Now, in order to answer your question, Marco, why have I decided to do research and to work in the scientific field? Now, I have to go back in time when I was a kid. My parents studied scientific subjects. My father is a geologist and my mother studied natural sciences. So when I was a kid and I used to go to the mountains with them, to me, it was wonderful because we could see the mountains, the flowers, the animals, mushrooms. And I was very curious. I used to ask questions to them, and they were qualified enough. They had the necessary skills to give me an answer. Hence, I became more and more curious because every answer you give to a kid can lead to a new question in the kid. Therefore, I've always lived science back home. And I also asked uncomfortable questions. For example, how big is the universe? What does it mean that it is an infinite universe? There must be something outside it, outside the universe. Is there God outside? So if you get till the end of the universe, can you meet God? So these were the uncomfy questions I would ask to my parents when I was a kid. And then the meeting in Rimini played a very fundamental role, and in particular, an exhibition that was organized by Euresis that was entitled Ready, Steady, Life. In that exhibition, for the first time, I heard about Miller's experiment, the experiment where you simulate the atmosphere and you can get the first amino acids. There was a panel focusing on the fact that probably life generated by chance on Earth. And there was an example. Just imagine that a tornado goes through a hangar, through a warehouse, where you have all the bits and pieces, the spare parts of a jumbo jet. And after the tornadoes has gone away, there's a plane that can perfectly work that has been created. But just by chance, it has been created by chance, and that aroused my curiosity. So I did like the fact that probably life has not come about by chance. So how has it come about? When I was in high school, there was a professor of chemics who was really very good, and I fell in love with chemistry thanks to him. I immediately liked the DNA. For example, I remember I made a drawing to show the helix of the DNA when I was a kid. But it's quite nice that now at Exoplanets exhibition, we have a DNA model. It's just, for me, it's just like a dream has come true. After high school, I studied physics at university. So I was no longer thinking about the origins of life. And then I got to the end of third year. I had to choose my thesis. And I remember that in the courtyard of the Department of Physics, I met Tommaso Bellini, professor at the University of Milan. He was one of my parents' friends, but I had never met him beforehand. And on that occasion, he told me I could do a thesis on liquid crystals and their possible implications on the birth and creation of life. I didn't understand anything at that time, probably just like you before I told you what it is. I hope that now things are clearer for you. But I got immediately interested in that topic, and so I decided to, let's say, join this project, and I started to go to the lab. And slowly but surely, I became more and more interested in this topic due to the beauty of the topic of this research. And bit by bit, step by step, I obtained some results out of this work. And the results showed that it would have been interesting to continue making research on this subject. I was in Milan for over 10 years, which is somewhat unusual for some scientific careers. Many friends of mine traveled for their thesis, then they moved for the PhD, then they moved for postdocs. This is the common way to have a scientific career. So sometimes I wondered that maybe there was something wrong with me. But that was not the case, because I could find some strong points, and I could understand why it was useful for me to stay for a very long time in the same place. First of all, because at the University of Milan, I found masters. First and foremost, Tommaso, and then an American professor too, Noel, who's based in Colorado, where I stayed for many months over the past years. So having real masters that you can follow, where you can understand that you can grow and mature, was one of the reasons why I decided to continue my academic career. Also, I learned a method, as in looking at scientific research. And to me, this method was brand new. I always give this example. It's an example I've heard from a dear friend of mine who said, The difference between Sherlock Holmes and Commissioner Maigret is that Conan Doyle is Protestant while Simenon is Catholic. And this can be seen in the way they make their investigations. Sherlock Holmes, for example, puts together all the different real aspects and uses a magnifying glass to get into the details of the murder in order to find the culprit. On the contrary, Maigret uses a different method. He plunges into an event, into something, until leaving the atmosphere of the case he's investigating. And he has a lot of empathy with the case, and he feels this case personally, and he makes an effort to understand the truth. And that also applies to the methodology I learned in the lab. You maybe imagine that a scientist would work just like Sherlock Holmes, focusing on details. But actually, what I found out is that the most interesting thing is to plunge into the phenomenon you are studying and use your instinct, your intuition to understand how the phenomenon works. Before measuring things, which is necessary because we do science, the intuition and observation are the most important things. That's why I want to thank them warmly. Thank you.
Grazie, Tommaso.
Thank you, Tommaso. And now I'd like to pose the same question to Stefano as well. How did you understand what your interest was and what are you working on? Thank you, Marco. I'm really very happy to be here. Thank you very much for the chance that you've given me to try and focus a little bit more on some elements that have characterized my working professional pathways. I'd briefly like to start with a short explanation of what I do. I am a research fellow at the Max Planck Institute in Garching. I am an astrophysicist. So I started studying at the University of Milan. I graduated there, then I moved to England for a PhD course at the University of Cambridge, and then went to Munich a couple of years ago, 3 years ago. So very briefly, my field of expertise is planetary formation, so the formation of the planet. Since the beginning of the 1990s, very clear observations can be made of star systems, systems of stars that are currently being created. At the moment in our galaxy, there are worlds, whole stars that are currently being formed. And around these stars, you have small disks of materials, relatively small disks of materials. And when I say small, I say 100 times the distance between the Sun and the Earth. And within these systems, there's direct evidence that has come to stay over the last 2 years that new planets are being formed within these systems. I do theory, so basically I work on mathematical, chemical, and physical planet models. So I am a theorist, basically. I work on models on how these formations basically characterize and influence the final characteristics of the planets being formed. And that is because the very same properties of planets, for example, of the Earth or the composition of the atmosphere, and the very same possibility that we have life in our planet, on our planet, are basically determined by the instance, meaning the millions of years, the astrophysical instance, in the very first instance in which planets are formed. So these first moments are the ones that determine the evolution and the potential habitability, so to say, the possibility to inhabit a planet. Very recently, I've started from, I've sort of moved from being a theorist to being an observer. In other words, I receive data from a station in Chile on the desert, on the Atacama Desert, which is one of the most beautiful places in the world. And so I also do observations. The most fascinating part of this research of mine needs, however, an explanation of how I started doing research in this field. And I also have to start from my childhood. Ever since I was a child, I've always had an innate passion for mathematics and for sciences in general. And this is a fact that has always been there, that has always been clear ever since my first year at primary school. And what fascinated me most, what impressed me most as a possibility, is the impressive possibility that man has to, in a way, recognize and describe an order that exists in the real world. This ability is, to me, a gift. And that is really impressive. There have been very precise moments. For example, during my 4th year at secondary school, I spent that year in America. And actually, I had the chance to realize exactly this. And that was evident. In other words, I realized the fact that we can describe very elegantly and with great preciseness certain elements of reality that would otherwise be without a shape, without a name. And it is indeed within this discovery and this realization of mine that I decided that I wanted to study astrophysics at university. Also, when I was a child, I recall a moment that I've often recalled in recent years, which is the moment when, as a child, I was at a friend's house in the area of Lecco, and actually the father of this friend of mine brought us outside and showed us the stars and started mentioning the names of the constellations. And I remember that it was really beautiful. It was really fantastic that, I mean, there was someone who was capable of mentioning, of giving a name to those constellations. Before that, those constellations were a fantastic group of stars, very distant from myself. But that was another very important moment. In other words, the possibility that we have, that I have, to give things a name, to recognize them, to describe them, and in this description create a link with the stars, a link that wouldn't otherwise be possible. It is exactly when you know the name of a person. I mean, if you know the name of a person, I mean, you establish a link with that person which is much stronger than before. There is a fantastic, famous passage of Genesis in which it is stated that the Lord sort of shaped all wild animals to know how he would basically name them. And whatever the name he would give to them, that was supposed to be their name. Ever since the beginning, and this is recognized in these first passages of the Genesis, man has this power, this responsibility of giving things a name. of describing and recognizing and, in a way, welcoming what otherwise would be a shapeless mass. One last passage. I'll be very brief. There was a passage, a moment between my PhD and the postdoc 3 years ago, in the postdoc period 3 years ago. There was a normal history, and actually these moments are normally characterized by lots of hesitations, lots of doubts, lots of hard work. Tommaso, for example, is an exception. He stayed for 10 years in the same place, but in our work, it is normally demanded that, you move 2 or 3 years. Every 2 to 3 years, you have to change down. A change, a country, and then relations, a culture. In this, with the potential, great potential to discover new things of the world, but at the same time, this is also a great sacrifice. So when I was called upon to decide if I were to continue or not after the PhD, I decided to continue because there was a unique opportunity to work within a very strong working group, scientific group that was doing research with a completely different approach than mine. And so there was yet another passage, another step forward. I became more mature in my scientific and professional route, which consists in the possibility of, in a way, placing the peculiar elements of my research in Cambridge, which is really very tiny. You need to be really very, very specialized. I needed to place that within a much broader horizon. So basically, at the end of my PhD, I felt that I was not capable of understanding how that research of mine was related to the rest of the astrophysical world. And how the study of these disks, of these protoplanetary disks, was related to the rest. This was fascinating for me, and there was yet another passage in these first years of research as an independent researcher. That's very different from doing a PhD. I had the chance of continuing to study, and in this continuous study, sometimes you understand the link that actually what you're doing has with the rest, with, for example, the evolution of the galaxy, or with other, with chemistry, for example, with the way in which life has formed. All of this is interconnected. And for me, that's one of the most interesting facts of my research. The possibility of finding the link between my specific area of expertise and the rest. And in this pathway of mine, living this experience is actually one of the things that most fascinate and satisfy me.
Grazie.
Thank you. Now, next question to both of you. You have already said something about it, but what is the reason why you continue working today with all the difficulties and the sacrifices required by this type of job? Each job requires sacrifices, and this one too. Why do you continue working? Where can you find the energy? often you realize in this type of job that energy must be given 100%. This career requires you not to have limits in what you do, to dedicate all your energy to that. There is many people working with other young researchers and dealing with similar topics. Many of them are here in the audience, and many of them have participated in the exoplanets area during this meeting, and you too. What has this experience given you? Has it given you some more motivation to continue along your careers? Now, there's many different reasons behind my job and why I continue to do my job. First and foremost, passion. As I said beforehand, if I had no passion, probably it wouldn't be reasonable to continue working on this topic. Also, the beauty of things that I'm studying. When reality unveils, and when you start understanding how things work, it's a very exciting moment for any researcher. Because it's like a sacred moment. For the first time, you can see with your own eyes in your lab something that no one else has seen. And my first reaction is to stop for a moment in silence, to pay respect to what's happening. And my second reaction is to tell anyone. The people who were in the lab with me have seen that. I started jumping here and there, and I want to tell anyone what I discovered. Then, with reference to the main reasons why I continue pursuing this academic career, is a reason that I have and that I can see at some difficult times. Because in daily life, we have to work on details which sometimes are difficult to identify, and that require hard work and maybe give unfruitful results. So oftentimes, for example, it's like you're wasting your energy or your time, or you're not taking steps forward. In order to do my samples, for example, I have to cut glass slides for the microscope, for example. And then I said to myself, well, you're here cutting the glass, but you are a scientist, you are a researcher. And I thought about my friends, some other friends of mine who were on the other side of the world and were doing something very important, whereas I was just cutting some glass. Now, at those times, or also, for example, when you can't see the results of what you're doing, I see that I start asking myself many questions like, am I doing the right thing? Should I change? Should I do something different? And often I tell myself, no, I want to understand how I can be useful to the world, how I can contribute to the world. And when I ask myself this question, I try to answer in an abstract way, in a way which is not connected to reality, simply by using the image of myself, the image of how my working life should be. I'm very grateful because every time this happened, there were friends who helped me to go back and to look at reality for what it was. And they showed me that when I asked myself this question, what is my task, is deeply connected to reality. And they also challenged me to ask myself this question. I found out that reality can provide practical answers. For example, a couple of years ago, at some point, there were some results that were not consistent. It was like I had no results. It was a critical time of my life, and I thought about changing my job. I had taught students in the meantime, and I thought that maybe I could become a professor. And at some point, I applied for a grant to get some money. And 2 years ago, I got this email where they told me that I got this grant. So I made a project, and this project was officially acknowledged. Somebody told me, yes, this project is worth it. So just do it. So you see, there's something telling you that what you are doing is worth it and should be done. It's worth doing. So you should stop thinking about changing your job, but rather you should think about using all your energy and focus on what you're doing. In September, I will move to Paris, where I'll have the opportunity to work in a new lab. It's going to be a small lab where I will continue my research and I will learn new techniques. So this is going to be a new opportunity. And I had to grasp this opportunity by using the same method, as in looking at reality in order to understand the situation and to ask myself questions about my career. So together with my wife, we looked at all details like children, money, my wife's job, to see whether this step was reasonable or not. And that was very interesting because the idea to move, although Paris is not that far away, but at the beginning you're some sort of afraid. But when you get into details and you analyze them, you can understand if it's something good for you or not. And so we decided that it was reasonable for us to accept this proposal. Lately, the main reasons why I continue doing this job, even if it's difficult, even if it's hard, also, we are young researchers. We've been doing research for not a very long time. So we haven't come to an end yet of our academic working career, but we are continuing our career, and we continuously try to understand what we have to do step by step. So my main motivation is to understand that there is a way ahead for me. Thank you.
To answer your question, I would like to start from a fact, which is how this exhibition how the idea of this exhibition came to life. About 1 year ago, myself and others felt the need to support each other, to focus on the ultimate value of our work and on how this is, so to say, faced with all the uncertainties and hard times of any type of work, especially of ours, exactly as Tommaso said. This is due to this very strange statistical anomaly. There's about 10 friends who studied together in Milan, and now we're all scattered all over the world between Cambridge, Munich, Belgium, Tucson, California, Milan. And we more or less work on the same topics, especially on planetary formation. And we often talk about these topics. We often talk about this. We try and support each other on important steps forward in our professional career, which, however, have implications in our entire life. And also starting from the relations with some of them, I felt the need to look inside the topic of our research, to be supported and to try and find out what the relation is between ourselves, between life, our entire life, so not only our professional life, and our type of work, meaning it's the type of work and the content of our work, the subject of our work, so the formation of the planet, the cosmos, and the exoplanets. The first thing I would like to say is that working on this exhibition, for me personally, went well beyond what I imagined at the beginning. And this week here at the meeting showed this clearly. We had the chance to talk to many visitors about the space. We had discussions. And for me, it is fundamental to have a place, to have an area in which we give the possibility of freely posing our questions, of freely asking questions without, feeling that without thinking of the fact that you still have open questions, even if you've been doing research for 6 years. An anecdote was particularly striking for me. Yesterday we were having lunch with some of the guides, and one girl was exactly telling me this. I mean, I was struck by the fact that I found a place in which we were not afraid of having questions without having answers to those questions. So she said I relaxed because of that. Because actually for me, alone, it is really very difficult to try and be on the verge between having legitimate questions on my own place in the world, on my career, on the subject of my work. If exactly as happened during this week, you don't find a place in which these questions can be asked freely, and they are in a place in which it is not considered strange that you still have questions after 6 years, because actually life is a way, a pathway. And to answer the question, what is the main motivation that supports me in my questions, as to some of the discoveries I've made, I've become more aware of the reasons. The first one is that my work consists in observing and looking at things which are unique, which are really beautiful and unique. I mean, my job consists in looking at the sky, looking at the planet, and see elements of reality. Elements which are formed in space, which are uniquely beautiful. In other words, what I do in life as a job is actually to look at this beauty. And I not only look at it, I can also be the first person in history, in the history of mankind, that actually looks at that specific data. I can be the first one. And so whenever you get new data, you want to immediately see what can be seen, because nobody knows that. And then also seeing these systems for the first time, systems in which new planets are formed. That's really very fascinating. But there's also another very important aspect for me, and I've become much more aware of that during these days. It is the fact that being, amazed of a data, even if that data is nice, if that amazement is not related to a link of that data with the entire life of mine, it can be tiring. So after some years, after some months, actually passion is no longer there. And I think that's a fact that characterizes all those who do research. And it is exactly from here, from this, that we thought about this exhibition. And there's a quote I would like to read out, which is basically the following what we normally show at the exoplanet exhibition. It is by Schroeder, an astrophysicist, one of the founders of quantum astrophysics. We try to understand what we are in the space and time of the place where we are at birth. And in trying to understand this, we find we feel pleasure. I mean, that amazement is really very interesting. So it is obvious, it is evident, and yet it has to be said. I mean, isolated knowledge, the isolated knowledge obtained by a group of specialists do not have a value per se, but they have a value only if they are related with the rest of knowledge. Because in this combination, they can contribute to answer the question who we are. Who are we? And this is valid not only in terms of scientific interdisciplinarity, but also at yet a higher level, the level that gives you the chance to realize that that scientific evidence, that discovery has a link with what we are, with ourselves, with the things that are dearest and truest, most authentic to us. And then there was yet another step, which is really fundamental. It was fundamental for me, also my personal evolution. A short quote by Don Giussani on the sense of religion. And I quote, when present data help man wake up, well, actually men realize who they are and actually become aware of the value of their own identity. So this capability of highlighting the extent and the significance of the identity of man. I mean, this is one of the most important moments of awareness that we did this year, and which is fundamental. It is really touching. It is also striking, impressive that we can realize and get astonished of the beauty that we have in front of us. We can be astonished by the entire universe we have in front of us from this very pale blue dot, which is the Earth, which is us. So this datum of reality, which is not significant if you consider the cosmos, the entire galaxy, but still we have the capacity of being astonished by that. And this possibility of astonishing ourselves tells us a lot of how big we are, of our own value, of our unreducible value. The unreducible value, which is then related to this capacity of ours to welcome what is outside me and to identify a relation, a link between what I wish, what I long for, with the strength that moves our heart. I would like to read out here another quote. I always like to read this quote when I finish the exoplanet presentations. I think it is very prophetic, and it is by Giacomo Leopardi. It is a part of the Zibaldone that was already read by Rose in the meeting on Sunday. No other things show the greatness and the power of the human intellect or the nobleness of man than the possibility of knowing and feeling the small characteristics of man. Actually, when men feel part of a globe, which is the minimum part of one of the infinite systems making up the world, actually, in this consideration, when man is astonished by his being so tiny and feels it and looks at it, and in doing so, actually, he sort of confuses himself with the void and then loses himself in thinking of things, and then finds himself confused in the immenseness of existence. Well, in this precise act and in this precise thought, man show how noble they are, of the strength and immense capacity of their mind, which has been capable to know and understand things that are so bigger of their own nature, and can embrace and contain with their own thought this immensity of existence and of things. But to me, I think that it is exactly this link between beauty and the vastity and the immensity and the intelligibility of the real, of astrophysics, of planet formation, in my specific case, and myself, what makes research worth doing. It is exactly this that makes research worth doing as a profession, because ultimately it is becoming increasingly clear for me that the most interesting part of this research of mine is myself researching, myself doing research, and it is in the relation. It is exactly in this link characterized by astonishment and almost vertigo, so to say, joy and sacrifice, linked, related to reality. It is exactly in this connection that I have the chance to understand who I am and what's my place. Okay, thank you.
Un'ultima domanda.
One last question to Tommaso and Stefano. What would you like to say to some young people, maybe younger than you, young students, or boys and girls? You both have said that when you understood your interest, you were kids. So what would you like to say to some young people who maybe think that they want to follow your academic career and to do what you're doing? Well, what I would tell them is that they need to be curious. So you need to be curious. It may be banal, but if you have this intuition, if you're curious, just go for it. Keep it alive. And try and find real masters who can help you understand and analyze this initial intuition. This is one of the reasons why I'm most grateful for what I have done so far in research. Don't be afraid of the challenges that might come ahead. Try and tackle challenges and face reality with no fear. Because reality can give either positive or negative answers. But I think it's the most interesting thing. Because only through that you can find out what your way ahead is. Now, following up to the question you asked me earlier on the work that we did this week for the exoplanets area. One of the things I learned was that I have to look at what I'm doing and what other people are doing, and to have an exchange with these friends and colleagues coming from different fields of research. I think that this experience has been very precious for our career. It's not that we've just been doing something beautiful or useful for participants this week. That was an opportunity for professional growth, and I hope that we will have the opportunity to do it again in the future. Working with all the different guides and all the different people who were involved in preparing the exhibition was very precious for me. They helped me to rediscover the beauty of what I'm doing and my interest in what I'm doing. One month ago, some young people came to the lab to see me, and together we looked at crystal liquids. I showed them the test experiments we do because they wanted to understand what we are doing, because that was necessary also to organize and work for the exhibition. So they got into the lab. I was explaining to them something. They approached the microscope. I put a slide, and then I put a drop of water on a DNA, and I said, look, we're not doing anything just by magic. Crystal liquids are created. And inside myself, I was saying, okay, let's hope this is going to work, because usually when you show something to somebody, things do not work. And crystal liquids appeared all of a sudden. And I saw that they were their mouth open, they were mesmerized, and this is something that I do every day. And I'm no longer mesmerized. I mean, to me, it's quite normal. And at that point, that moment, I saw that excitement, and I thought back about what I used to feel, and that was very important for me. Also, there was something else I was really struck by, as well as the people who came to see the exhibitions, and in particular Antonio Lazcano, who actually didn't know the meeting and has a totally different story. He is a very strong atheist, and he told us before going away, I've never felt so familiar with a place I didn't know. Here I could find many friends, and he was impressed by the fact that many people would come and look at this exhibition, were so interested in such a scientific subject, and that we were there to talk to something that is quite extreme to varied people. And he was most struck by that. So if there are young people who are interested in science, well, you have to know that this has enormous value that we always have to recall, and we need to nurture this value with gratefulness.
So very briefly, some things have already been mentioned by Tommaso, so I'm not going to express his thoughts again. As far as I'm concerned, and also as far as I can say from what I've seen in other people, there are 4 things that should be mentioned. The first thing is that for those who perceive this interest, this peculiar interest, maybe what I'm saying might sound a little bit banal, but actually for those who feel this interest, my suggestion is that they try and cultivate this interest and follow their interest, as Tommaso said, also by meeting people who do this as a profession. That was fundamental for me. That was fundamental in the time, back in time, and also now. I mean, also the possibility of seeing how others with different sensibilities. It's interesting to see how others experience this particular interest, because this can give you, for example, possibilities, opportunities that you otherwise would not think of. The second thing I would mention is, to have no limit. To do not set yourselves any limits before. Sometimes there are friends at university who may say that they have a desire, they have a wish. Maybe they studied physics, they studied sciences, and they would like to start and work with a given group, but it is impossible. So, in advance, they think that that thing is not possible because maybe that scientific working group works in Harvard or in big places that appear to be impossible to reach. And I could make tens of examples of very dear friends, and with some of them, we were talking about that, and we would say, just drop a mail. Just drop a mail. In many of these cases, for example, I have a friend who sent a mail in one of the biggest groups in Caltech, studying exactly what he does, and actually his mail was immediately taken as a PhD student, and now he works in Caltech, one of the top 4 and one of the 4 American universities in science. Or I have another dear friend who wrote a mail, who sent a mail to a Nobel Prize winner, and is now working with this Nobel Prize winner. And then there was another friend who wanted to be an astronaut and risked on that. He bet on that. So he got information, he made a master course, and now he works at NASA. And I met him a month ago in California. All of these are examples of people who took risks without posing themselves too many limits before in advance. This doesn't necessarily mean that you're going to be successful, but it might be the case that reality opens up new opportunities just if you try. Otherwise, if you don't try, you will not be successful. So, it's worth taking risks. And then one last thing I'd like to say is that is not to be afraid. Don't be afraid to have questions. I mean, when you see that there's interest towards what you're doing, you don't know how to place what you're doing compared to what you have. I mean, I have lots of interests, not only science. And you always fear that you're losing bits if you follow others, if you try and pursue one objective. This is an open question, this is an open issue for me as well. But my suggestion is that you shouldn't, you shouldn't, in a way, not address certain questions before exploring certain possibilities in your own way with open questions. And I'm saying this because myself, in the first place, and not only me, also many other people have the same fear. I personally have fear of showing my questions and also of accepting that I still have open questions, while actually this is very good. And this is still happening, this is still taking place even after 6 years that I've been doing research. It's not a problem if I have these sort of questions following me, because gradually the answer will come. Thank you. I think that we've had lots of rich insights after a meeting. I think this was really the example, sometimes touching testimony of a pathway, of an ongoing pathway, which is a serious one in a very peculiar field. That was a real testimony. For example, Stefano was mentioning this issue of the questions, and at least for me, and after these days here at the meeting, this is one of the most fascinating aspects, and that testifies once again of the importance of being aware of things. I mean, there's a thrill that comes from having open questions, from having questions that still have to find the evidence that justifies these questions. And in this waiting for questions, you find the human. It's the almost void, the almost null by Leopardi. Leopardi who sees. Or you were mentioning a guide, I mean the friend, you were mentioning a place where you're not afraid of having questions without answers. This relaxed me, you said. Because actually you start enjoying the pathway, the way you're going along. And this also in science, science. I mean, we've seen these days that vis-a-vis the big question of whether we can have other forms of life in the universe, we don't have the answer to this question. And it is really beautiful to get enthusiastic, to get thrilled by the fact that the more you pose yourself this question, the more elements you may have to answer it. And so it's beautiful to be open towards an answer that is still not there. When Tommaso said, as a child, you were going to the mountains with your parents, you were given answers, and the more answers you received from them, the more curious you became. So the answer goes in hand with an increasing curiosity. What can this position lead to? I mean, you don't leave the question open, but that, I mean, contributes to increasing your satisfaction. That has to deal with something that you both mentioned, with this sort of relationship with the totality, with the awareness that any peculiar detail is within a specific order, which is mysterious but real, and you are related to that wholeness, to that whole. So you can look at that whole with great affection, so that whenever you have a new piece of data, you look at that data, and that helps you give a name to that thing that had been up to that moment unknown. And in being answered, that becomes human. This has to deal not only with interdisciplinarity, but it has to deal with the wholeness of the person. And I think that your examples showed this very clearly. You were really very convincing and opened up new perspectives, especially for young people. But even more, much more than for young people, for people like me, who are no longer young. Because the most beautiful thing in growing, as long as time goes by, is that you notice that you learn more and more, starting from those who are younger than us. So thank you very much to Tommaso and to Stefano. And I would like to remind you that it is always possible, if the meeting is about to end, it is always possible to support the meeting with donations, the donations that can be made in the Dona Ora stands, marked with the red heart that you've probably already noticed. Thank you very much.